Okay, in this video, I will go through Mechanics 1, Chapter 10, Section 10.6, Pulleys. In previous video, we went through the example 15. Okay, in this video, we will go through example 14. Let's go through the question first. Two particles, A and B, of mass of 0.4 kg and 0.8 kg respectively are connected by a light inextensible string. Particle A lies on a rough horizontal table 4.5 meter from a small smooth pulleys which is fixed at the edge of the table. The string passes over the pulley and B hangs freely with the string out 0.5 meter above horizontal ground. A frictional force of magnitude of 0.08 G Newton opposes the motion of particle A. The system is released from rest. Find A, the acceleration of the system. Okay, to find the acceleration, first and most important thing, let's draw the diagram for this question, okay, which I have already done just to save our time, but we will go through the pointing out actually the forces better. Okay, so here is particle A, here is particle B. Okay, so particle A is 0.4 kg. Okay, there is a force 0.4 G newtons downward. Of course, there should be reaction force for A from the table. Okay, let's call it R of A. However, most likely we won't need actually this. And 0.8 kg for B. So 0.8 G Newton downward. Okay. So what else? 0.08 G, which is a frictional force. So it would be this force. Okay, so 0.08 G Newton. Okay. Right. What other forces? There is tension in this direction and tension in this direction. Similarly, tension for B in this direction and from B in this direction. Okay, so let's say acceleration is in this direction. Because if the system is released from rest, so it will move in this way. Okay, and of course for this one, I could write A downward. Okay. We wrote down all the information for this problem. Now, we've been asked to work out the acceleration. Okay, let's write down the question. The acceleration of the system. Okay. To find out the acceleration for the system, we need to write down two equations. One for A and one for B. Okay, for A and for B. Okay, for A, we really don't need reaction force and 0.4 G Newton at all because the particle is not moving up or down. The acceleration upward or downward is zero, so therefore we don't really need to write down the forces in these directions. So let's write down force in this direction. So it's moving in from left to right. Therefore, T is positive and 0.08 is negative, which is the frictional force. T minus 0.08 is equals to mass times by acceleration. Let's call this one equation 1. For B only, so we've got T in this direction 0.8 g downward. 0.8 g is positive because it's in direction of the acceleration. So R, let's say downward. So it would be 0.8 g minus T is equals to mass times by acceleration. Let's call it equation 2. Now, adding equation 1 and 2, okay, add 1 and 2. What do we get? T minus 0.08, which I forgot to write g here, 0.08 g, okay, plus 0.8 g minus T is equals to 0.4a plus 0.8a. Okay, so we know from pure maths, if a is equals to b and c is equals to d, a plus c is equal to b plus d. Okay, that is what we did here. T minus t is 0. 0.8 minus 0.08, which would be 0.72 g is equal to 1.2a. Okay, divide both sides by 1.8 and 1.2, you get a equals to 0.6 g meter per second. However, you can substitute 9.84 g and work out the numerical value, okay, for a. Let's move on to part B and C. Okay. For part B, it says the time taken for B to reach the ground. The time taken for B to reach the ground. Okay, it looks like I have to move the paper a bit. Okay, right. To do this, let's draw another diagram. Okay, here is the ground. B was initially here. Okay, so acceleration in this direction. The distance of B from the ground was 0.5 meter. Okay, what the question was already saying. Right. Of course, when it's asking about the time, here we're going to make a link between Newton's law and the Stewart equation. Okay, so let's write down all the information which we've got. SUVAT. So we know that S is 0.5. Initial velocity is 0 because the system is released from rest. Okay, 0. We are not really interested in velocity. We worked out the acceleration, okay, and the acceleration will be the same all the way down up to when B is hitting the ground, 0.6 g. And we are interested to find the time taken. So S equals to ut plus half a t squared. Okay, so 0.5 is equal to 0 times t at half times 0.6 times by t squared. Okay, so this one becomes 0, multiply both sides by 2 and divide by 0.6. T squared is equal to 1 over 0.6 g. Okay, 0.6 g. Since time is positive, we square root this 1 over 0.6 g. Substitute 9.8 for g now, which you should get t equals to 0.41 seconds. Okay, so end of the part B. Let's move on to part C of the equation, which is probably the most important part of the equation. Okay, the question says the total distance traveled by A before it first comes to rest. The total distance traveled by A before it first comes to rest. Okay, to do this, I have to explain few things from the diagram. One, we know that this distance is 4.5 meters. It says in the question. And this distance is 0.5. Now, let's imagine B hits the ground. B is here now. Okay? So what would happen? A would be at this point. Okay? However, there is another 4 meters left over here. Okay? After B hits the ground, what would happen? A will still continue moving. Okay, because the rope or string will become a slug and it's not gonna to have any impact on these two particles. Since A has already acceleration, it will keep moving until this friction force doesn't allow it to move anymore. So let's say we are not 100% sure now whether it's gonna to move up to the pulley, it will hit the pulley or not. So let's imagine it will move up to this point. Okay, so we know that. Let's call this point D. Okay, so the total distance which A will travel, okay, let's write total distance is equal to D plus, let's call this with E. Okay, we know that D is 0.5. Okay, D is 0.5 meter. So we would work out E. Okay, to work out the distance E, okay, we should know the initial velocity for A. Okay, the final velocity obviously will be 0. It will stop here, or even it could stop next to the pulley. Okay, however, the final velocity is 0. Okay, We don't know how long it will take, so therefore we don't know the time, and we are not really interested to find the time as well. Okay, so we really want to work out u first, initial velocity for a at this point. Okay, so which will be the final velocity of a from here to here. Okay, so find the speed of b when it hits the ground. So why we want to find that? Because when b hitting the ground, it will have the same velocity as a at this point, because up to this point they are connected and the string have impact. Okay, so find b, speed of b or velocity of b, speed of b when it hits the ground. Okay, let's write down all the information for b. Initial velocity was equal to 0. Acceleration was 0.6 g or 5.88. T is equal to 0.41. Okay, so it was 4.1239. For more accuracy, we can use the whole number rather than the rounded one. And we want to work out velocity. Okay, so velocity of b when it hits the ground, it would be, we could use v equals to u plus at. Okay, just to save the space, I just write down on the same row. Okay, u is 0 plus 80, 5.88 times by 0.41239. Okay, which is, so I call v of b. V of b is equal to 2.42487 meter per second, which is equivalent to u of a at, let's say, point, let's call it c. Okay, now we want to calculate this speed. We know the acceleration up to this point is equal to 5.88. But what is acceleration at this point in this direction? We need to work out that acceleration as well. Okay, speed of a, so which we worked it out at point c. Okay, once b hits the ground, the string will go slack and a will begin to decelerate as it slides against the friction, okay, on the table. So what would happen after b hits the ground? I can draw a diagram. Here is a. Let's start to move in this direction. Okay, so we don't have the string anymore. Okay, however, there is friction force in this direction, 0.08 g. So there is no force in this direction, okay, because the string will obviously wouldn't have any impact. So what would happen? Let's write down the Newton's law for this. sum of the forces is equal to mass times acceleration. It's moving in this direction. No force in this direction, 0 minus 0.08 g. 0.08 g equals to mass times, so we know the mass of A is 0.4 times by acceleration. I call this acceleration A dash or A prime, just in case not to mix with the previous one. Okay, so A dash is equal to negative 0.2 g meter per second. It is negative because the speed is reducing. Okay, so far we've got acceleration for this speed. Okay, so it's gonna to finally move up to this point. Okay, so what we've got here, u of A, which is the same as v of A at point C. So therefore, u of A, which we already worked out, v of A at point C, 2.42487. Okay. Final velocity at this point obviously is 0 because A will completely stop. Okay. 0. A prime acceleration is not point, or deceleration is negative 0.2 g meter per second. Okay. And finally, we want to work out distance, which is the same as I wrote down E here. Okay, so S equals to ut plus half at squared. Okay, or maybe we could use, because we don't have time taken here, so I wouldn't use this one. It will require extra steps. So I could use v squared equals to u squared plus 2as. Okay, so v is 0, therefore 0 squared is equals to 2.42. Okay, and so on, the full number, all squared, minus 4 times negative 0.2 g times by s. Okay, so if we rearrange this equation for s, which I leave it for you to do it yourself, s is equal to 1.5 meters, which is the same as s is equals to E from our previous formula, which is equals to 1.5. Therefore, the total distance would be, total distance traveled by A will be 1.5 plus 0.5, which is 2 meters. Okay, which means it wouldn't hit the pulley at all. Okay, after this lesson, you should be able to do exercise 10F. Okay, I just write it here. Lesson for exercise 10F. Okay, which is page 175 and 76 and 77. Okay. Of course, you need to watch the previous video for example 13 as well to be able to do this.